The blue squares are the bad equals. On the face of it, it doesn't look like there is any pattern there. It looks as if all these points are spread all over the place. But if I draw a line like this, you can see that all the points above that line except one is a good account. Similarly, all the points below that line except one is a bad account. In that sense, this line is able to discriminate between the good accounts and the bad accounts. So this is called the discriminant line, since it is able to discriminate between two different categories. This line also gives us some additional insights into the domain knowledge. What the line is saying is, if my return on investment is low, but at the same time, if my CR, current ratio, is high, it's likely to be a good account. Same thing if it is the other way. If my current ratio is low, it can be compensated by high return on investment. So in that sense, the current ratio and the return on investment compensate for each other. This is an additional insight into the domain knowledge. Now, in the case of discriminant analysis, the entire idea is, how do we fit this line? The line should be fitted such a way that the distance between the line and the points is to be maximized. If you look at the regression analysis, we would like to minimize the distance between the line and the points. Compared to that, in discriminant analysis, we are trying to maximize the distance between the points and the line. The farther the point is from the line, the better is the classification. But those of you familiar with calculus, you will understand that whether I am maximizing or minimizing, the technique is the same. I will take the first derivative equated to 0. Then solve the equations. The process is exactly same here also. So in that sense, the discriminant analysis is not very different from the regression analysis. As a matter of fact, you need not worry about it. As a matter of fact, you can put all your data into SPSS, define what is your dependent variable, define the categories of the dependent variable. Like in this case, there are two categories. It's possible you may have 3 categories, even 4 categories. Then identify your explanatory variables. Ask SPSS to give you a discriminant line or discriminant lines. Depending upon the number of categories in the dependent variable, SPSS will fit different number of discriminant functions. For example, since I have only 2 categories here, one straight line is able to differentiate between the 2 categories. If I have 3 categories, I need 2 functions because I have to divide the entire area into 3 segments. So the general rule is, if I have n categories, I will need n-1 discriminant functions. These discriminant functions, the coefficients of the discriminant functions, can be tested for their statistical significance. Based on the statistical significance, we can decide whether a particular explanatory variable should be included in our equation or not. But please keep in mind, the coefficients that you obtain in discriminant analysis cannot be interpreted exactly the same way as that of the regression equation. The reason is, the dependent variable is categorical here, whereas it is metric in the regression analysis. So please be careful when you are interpreting the discriminant analysis and the coefficients of the discriminant functions.